Welcome back to the Python Praxis. Today we're diving into one of the most exciting and important topics in programming: operators and control flow. Think of operators as the tools in your coding toolbox. They let you add, compare, and make decisions. Control flow, on the other hand, is like the roadmap of your program. It decides which path your code takes depending on the situation. By the end of this lesson, you'll not only know how to calculate with Python, but also how to make your program smart enough to choose what to do. Let's begin. In Python, we use expressions to perform calculations or logic. These expressions often involve operators, which help us build more complex behaviors from simple values. And Python includes several types of operators. But what exactly are the operators? How do we actually do those expressions? The operators are special symbols, like plus, minus, or equals, that tell Python what action to perform. There are 5 main categories of operators in Python. Arithmetic operators, used to perform basic math. Assignment operators, used to store and update values in variables. Comparison operators, used to compare values, either numbers or even strings, to check if things are equal or different. The result is always Boolean, which means it is either true or false. Logical operators, used to combine or modify Boolean values. The result also here is always a Boolean, which means it is either true or false. Bitwise operators. These deal with binary data and binary level operations. They are more advanced and are mostly used in low-level programming. Don't worry, we'll go through them one by one. Arithmetic operators are the bread and butter of math in Python. We have plus for addition, for example 3 plus 2 equals 5. Minus for subtraction, like 5 minus 1 equals 4. Star for multiplication, like 4 star 2 equals 8. A single forward slash for division, which always gives a float number. So 8 slash 4 equals 2.0 and not just 2. 2 forward slashes for floor division, which cuts off the decimals and gives only the integer part. For instance, 7 slash 2 equals 3. % for modulo, which gives the remainder of a division. For example, 9 modulo 4 equals 1. And finally, 2 stars for exponentiation or power. For example, 2 star 3 equals 8. In Python, you can even compare strings. String comparisons are based on the lexicographic order, which means alphabetically. Python considers lowercase letters greater than uppercase letters. For example, checking if zebra is greater than apple will return true. Now let's move to the assignment operators. These are the ones that store or update values in variables. The simplest one is the equal sign. It assigns a value to a variable, for instance, x equals 5. But Python gives us more assignment operators to use as shortcuts. The plus equals operator that adds and assigns, where x plus equals 2 is the same as x equals x plus 2. Actually, in this example, with this shortcut assignment operator, we increase the value of x, adding 2. The minus equals operator that subtracts and assigns. Here, the x minus equals 1 is the same as x equals x minus 1. This shortcut decreases the value of variable x by subtracting 1 from it. The star equals operator multiplies and assigns, so x star equals 3 is the same as x equals x star 3. In this case, this assignment operator multiplies the value of x times 3. The slash equals operator that divides and assigns, where the x slash equals 2 is the same as x equals x slash 2. This shortcut takes the value of variable x, divides it with 2, and stores the result to variable x. In this case, the result is a float number. The double slash equals operator floor divides and assigns, so here x double slash equals 2 is the same as x equals x double slash 2. This shortcut actually floor divides variable x with 2 and reassigns the result to variable x. These shortcuts make your code shorter and cleaner. The next category of operators is the comparison operators. Comparison operators let your program ask questions like, is this value equal to that one? Or is this number bigger or smaller than the other? The result is always Boolean, true or false. Let's see these operators one by one. With 2 equal signs is the equality operator that compares either two values or variables or expressions. In case the expression on the left side of the equality operator is equal to the value on the right side of it, it returns true. For example, 2 plus 3 equals 5 returns true. An exclamation mark next to an equals sign is the inequality operator that checks whether two values are not equal. If the values are not equal, it returns true, and if they are equal, it returns false. For example, 6 not equal to 7 returns true. The right arrow is the symbol for the greater than operator that checks and returns true if the value on its left side is greater than the value on its right side. Similarly, we have the left arrow for the less than operator, the right arrow next to the equal sign for the greater than or equal to operator. And last one is the left arrow next to the equal sign for the less than or equal to operator. Here are some more examples for the use of these comparison operators. 9 greater than 3 gives true, 2 less than 5 is also true. 5 is greater than or equal to 5 is also true, and 4 is less than or equal to 7 returns true as well. Simple, but extremely powerful when combined with conditions. Now, what if you want to check more than one condition at the same time? That is where logical operators come in. We've got 3 logical operators. The AND operator that returns true only if both conditions are true. For example, if we have a condition A or a Boolean that is true and another condition B that is false, then the AND operator will return false. And only when both are true, the AND operator will return true. The OR operator now returns true if at least one condition is true. This means that the OR operator will return true if either of the two conditions or both of them are true, and will only return false if both conditions or Booleans are false. The third logical operator is NOT, that simply flips the value from true to false and from false to true. This means that if a Boolean is true by adding NOT operator in front of it, it becomes false. Here is an example of logic operators in action. Imagine it's sunny but is not weekend. If you check whether it is sunny and weekend, using the AND operator on Booleans sunny and weekend, it returns false, because only one of them is true and the other is false. But using the OR operator for sunny or weekend returns true, because at least one is true. By adding NOT before weekend returns true. So if we check now, sunny and not weekend returns true, because sunny is true and the NOT operator in front of weekend flips it from false to true. Logical operators are the secret sauce behind smart decisions in code. Bitwise operators are special. They let us work at the binary level with the zeros and ones inside the computer. We have AND, we have OR, we have XOR, and we have NOT. We also have shift left and shift right. These operators are mostly used in low-level programming or hardware control. For now, just know they exist. We'll cover them in detail in later lessons. Here's where things get interesting. What happens when you mix different operators in the same expression? That's where precedence comes in. The order Python follows. First come arithmetic operators, then bitwise operators, then comparison operators, and finally come the logical operators. Within the arithmetic operators, exponentiation happens first, then multiplication and division, then addition and subtraction. The priority of the operators as depicted in this table is from top to bottom and from left to right. The bitwise NOT operator in Python has a very high priority. It is just after exponentiation. Let's see some examples now. 6 plus 3 star 4 equals 18 because multiplication happens first. But if we add parentheses to 6 plus 3, the calculations inside the parentheses have higher priority and are calculated first. Then the multiplication times 4 is applied to the result of the calculations inside the parentheses, and the answer changes to 36. In the next example, we have both arithmetic and comparison operators. 3 plus 2 is greater than 4 gives true because first Python calculates 3 plus 2, that is equal to 5, and then proceeds to the comparison, 5 greater than 4, and returns true. Similarly, 10 minus 3 equal to 6 returns false, because subtraction is done first, that gives 7, then compared with 6 gives false because they are not equal. Next examples have logical and comparison operators. 5 greater than 3 and 2 less than 4 returns true. Because comparisons happens before logical check, and because both comparisons are true. In the next example, 5 greater than 3 or 2 greater than 6 returns true. Because or needs only one true statement to return true. In the last example of not 5 greater than 3, the return is false. Because 5 greater than 3 returns true, which is then negated with not operator. Mixing everything together, and we see the precedence in full action. In this complex example, we have a variable named result, to which we assign the result of a complex expression. That includes arithmetic operators like addition and multiplication, comparison operators like greater than and equal to, bitwise operator and, logical operator not, and logical operator and. Step by step now, Python solves it, and the final result is false. Let's analyze how this is done. In the first step, Python performs the arithmetic operations, multiplication first and addition second. 2 times 4 gives 8, then 8 plus 3 gives 11, and then 11 greater than 10 returns true. We keep this for step 4 later on. In the second step, Python performs the bitwise operation AND. Converted to binary system number, 8 is written as 1000, and number 3 is written as 0011. 8, bitwise AND, 3 in their binary forms return 0. Bitwise AND operator checks bit by bit the two numbers in their binary form, and if both have 1 at the same position, returns 1, while in all other cases returns 0 for that position. The resulting binary is then converted back to its decimal form. In our example, binary 8 has 1 in the 4th position only, and 0s in the rest 3 positions. Binary 3 has 1 in the 1st and 2nd position, and 0s in the 3rd and 4th. Hence, the resulting binary number is 0000, that in decimal form is 0. Then Python compares this result with 0 and returns true. In the third step, we have not operator, that flips the previous true result to false. In the fourth and last step, we have the logical AND operator between the true from the first step and the false from the third step that returns false. Precedence makes sure everything is consistent. Let's put this into practice with an example. You are building a quick self-check to decide whether your sleep pattern is balanced. You'll create variables for sleep hours, cups of coffee, and whether you feel rested. Then you'll combine them with logical operators to decide if the pattern is healthy. Here's what you'll do. Create an integer variable named sleep hours for how many hours you sleep per night. Create another integer variable named coffee cups for how many cups of coffee you drink daily. Create a Boolean variable named feels rested that takes as values either true or false only based on how you think you feel. Then you define a new variable called healthy pattern, which is true only if you sleep at least 7 hours, you drink less than 3 cups of coffee, and you feel rested. This means that Boolean variable feels rested is true. In our code now, we assign to variable sleep hours the value of 6, then assign to variable coffee cups the value of 2, and last we assign to Boolean variable feels rested the value true. Then we have the variable called healthy pattern, to which we assign the complex expression sleep hours greater than or equal to 7 and coffee cups less than 3 and feels rested. The result will only be true if all 3 comparisons are true. Meaning, sleep hours is greater than or equal to 7 is true. Coffee cups is less than 3 is also true. And feels rested is true. In our case, the healthy pattern is false, because the sleep hours is 6, which is less than 7, so the first comparison is false. This is a great way to see how comparisons and logical operators work together in real life. In this first part, you've learned what operators are, the different categories of operators in Python, and how each of them works. You have also seen examples with the operators in full action. In the second part of this lesson, we will proceed to control flow. Until then, keep practicing, keep experimenting, and as always, happy coding.